welcome to the Spokestack Maker launch live stream. Thank you for checking us out. We're really excited about this product. It's something that we've worked on, kind of thought about for a long time, dreamed about a little bit, then worked on for the last basically since the beginning of the year. And so it feels great to get it out there into the world. And it feels, and we're really excited to show it out to everyone. We hope we have found it super useful internally for building mobile apps and even web and embedded applications that use voice. So we think that it has a lot of potential for people who are encountering the same use case problems. So where you want to put voice into your software, but you find it too hard. So voice in software is like a difficult field. I kind of break it down two ways. One is like there's a engineering problem. So you need to have the machine learning chops and in specifically in machine learning, like the field of voice in machine learning is actually an even more difficult subdiscipline of machine learning. And so even if you're familiar with, say, computer vision, your intuitions and some of the tools and patterns that you can take advantage of are actually not going to apply at all, and you need a whole different discipline of like computational linguistics to be able to start working in machine learning for voice. So it's a big ramp up, even if you're a practitioner in the machine learning field. If you're not a practitioner in the machine learning field, you're just a developer, perhaps a mobile developer, game developer, web, or even just a hobbyist, putting together a home assistant style system for yourself, or you want to play around with just voice on embedded devices. You're also going to run into some similar issues. In mobile, the ecosystem is fragmented, and the built-in voice assistants from Apple and Google aren't, and Samsung for that matter, aren't really interoperable with each other. They also don't do a great job of giving you voice interactivity once you leave the voice assistant. So once you're actually in your mobile app, they then exit the conversation, and now you're stuck with having to piece together, how to use each platform's ASR. They don't offer NLU, so you can't use that. You might use the new hey, hyperparameters, welcome. They might use the default Siri or Google Assistant TTS, or you might pay for a cloud provider to do that, like Microsoft Poly. So in other words, it's fragmented, and that's just on mobile. If you're talking embedded, then you have even less support. You do have some nicer open source tools to take advantage of, but it's still hard. So and then in web, Mozilla did a lot of work with the Open Voice Initiative, but that has kind of stopped. So they made some good progress, but then that has come to an end, and we still don't have good voice interactivity, good voice interface in the browser. So for both mobile and web and embedded, there's still a lot of work that you have to do as a developer to be able to put voice into your software. On top of that, we already talked about the machine learning expertise that you need. So we at Spokestack have basically a two-part solution to this. One is we have built these tools internally, these open source libraries that run on all these platforms. So an iOS library, Android, Python, Node, and we did this because we needed it to build what we were trying to build at the time, and then we realized that these were applicable, for more than just us, and so we open sourced them, hoping to see other people be able to use them successfully. So, and then the other piece to this is, of course, these open source libraries for the different platforms, they let you take advantage of some of the built-in components of voice interfaces, like a platform ASR, for example. So on iOS you get the Siri ASR, and on Google you get the Google ASR. But for something like Python, you're not going to find a built-in platform ASR provider there. So they all give you the ability to run your own custom on-device machine learning models for voice, for wake word, for keyword, for TTS, for ASR, for NLU. And we see those as the major components of what you need to be able to do a voice interface in your software. How do you create those models? That's the question that we're now at. The answer that we have come up with is Spokestack Maker. Spokestack Maker lets you create these custom personal machine learning models for voice, for keyword, for wake word, and for TTS, and for NLU. And so you can create your own models that wake up to your word, to your words. They can recognize the commands that you want your software to recognize. They can process those commands using an NLU that you define, and then you can speak back to your users using your own TTS voice. So we think that Spokestack Maker solves the other part of this problem that I laid out. How do you get custom voice interfaces on different platforms? Spokestack Maker lets you, gives you like a no-code way to create those models, train them, test them, distribute them, and then the Spokestack open source libraries let you actually run them in your software. So that's a bit of the overview and history of what Spokestack Maker is. To kick things off, I'd like to introduce each member of the team. So I have a couple questions that I'm going to ask them. Let's start with Josh. Josh Ziegler is our Chief Computational Linguist. I think I just added Chief to your title right now. Congratulations on
I'll take it. Thank you.
Congratulations on the job title upgrade. And he's been invaluable in providing everyone with an understanding of what the discipline of computational linguistics and how voice works, both linguistically and computationally. In addition, he's also the platform library maintainer of our Android software, as well as doing a bunch of machine learning and really everything else that needs to get done. He's also the initial author of a lot of the documentation that you're going to read on the site too. So Josh, my question for you, what was the most exciting feature in Spokestack Maker for you?
Well, for me, despite it not being one of the ones that I was as intimately involved with as some of the others, I think the most exciting Maker feature is the personal TTS voice clone, because I think there's a lot of untapped potential for this particular part of voice technology being democratized. You see the other technologies used by a lot of different companies for different things, but I'll get into this a little more when I sort of walk through the UI. But I think there's a lot can be done with a personal TTS clone.
Awesome. And when you're creating your pieces of Spokestack Maker, what was the biggest challenge that you had to overcome?
So the biggest challenge for me, I didn't have a lot of the big technical challenges involved in Maker per se, because I did a lot of the back-end work for the stuff that you see on the site. I think the biggest challenge of Maker overall is the automated training framework that makes the whole no-code, low-code thing possible. And again, I didn't do a lot of the implementation there, but I think that's the most impressive and most challenging bit. Outside of that, it was probably negotiating the actual audio recording with the site itself for recording your wake word and TTS samples. Wasn't too bad though.
Nice. Thanks, Josh. We'll get back to you to the walkthrough of Maker in a bit. Next, I'd like to introduce Elizabeth Ropp. She is our head designer, our product lead, our marketing lead, one of our writers as well. If you all the illustrations, the website you see, that's all her designs. She's our social media manager as well. So all the tweets are coming straight out of her keyboard, straight to you. And she's a wonderful part of our team. Elizabeth, same questions to you. What's the most exciting feature of Maker to you?
I mean, I hate to harp on what Josh said, but I would also agree the TTS voice. I remember when we trained the free Spokestack voice that we had. Full disclosure, that is my brother. We paid him for like hours in a studio, and he kept texting me like, "What are these scripts that I'm reading? Like, I don't know what this is." But now anyone can do that themselves in their home. They don't have to go to a studio to record that level of audio. I mean, I think that's pretty cool.
Yeah. No, I mean, it's been a big transition from like hundreds of or dozens of hours in a Hollywood recording studio to just doing it. I recorded mine, in my bedroom closet with like 10 minutes of work, which is pretty cool. What's the biggest challenge that you had to overcome when you're creating Maker?
I will say it did take a while for us to come up with a simple way in the UI to communicate everything that you're capable of doing in Maker. A lot of back and forth. We tried to, probably the hardest thing was coming up with a way to show all the recordings in a way that was convenient enough that you could go back through them and hear them and take out recordings that you don't want or edit.
Awesome. Yeah, the conceptual part of designing this of designing like a no code machine learning interface is a big challenge.
Yeah.
Thanks, Elizabeth. Next, I'll introduce Will Rice. Will is one of our machine learning engineers, and he comes to us with a master's in computer science, and has been working on many different parts of Maker on the back end, on the machine learning end, and has a lot to do with how specifically the NLU and ASR and a bunch of other pieces too are working in Maker. Will, what's the most exciting feature of Maker for you?
The most exciting feature of Maker for me is the keyword model, because it's pretty much you actually don't need NLU for that, and you can put it into a lot of applications pretty easily. So yeah. The keyword model is a really cool feature. It's multilingual. Is another part of this, which is really cool. What's the biggest challenge that you had to overcome when you're creating Maker? The biggest challenge was making sure the Python library would literally run on anything that runs Python. There were a lot of hurdles in that as far as C dependencies and whatnot. So
yeah, the getting many like getting the device support as broad as possible. Yeah, and it's hard on any platform, let alone like an unregulated Wild West one like Python. Thanks, Will. Last person is Timmy Willison. Timmy is our lead front end engineer. He is, in addition, so he's also the maintainer of our Node library, of our React Native library. He's also the jQuery core team lead. So he's in general a JavaScript, one of the most expert of JavaScript people that I've ever met. So Timmy, tell me when you're talking about Maker, what are you most excited about?
Well, I was going to say creating your own voice, but that's taken by two people. So I'm going to go with making your own wake word without needing anybody else to, just completely self-service thing where you could just build your own wake word. That's pretty cool, because I don't know of other services that provide that. and to be able to put that in your own app. And it all depends on the number and quality of your recordings, and that determines how good your wake word is. So it's up to you to make a quality wake word.
Nice. Yes. Yeah. The even just this is not to keep talking ourselves up, but like running a wake word inside a web browser, which is something that you helps you make is a unique thing. Like so, a web page for the first time can be activated, with a wake word custom wake word that you train, and it runs natively in the browser, so there's no cloud involved, and that's one of the things you helped create with that.
That was going to be my answer for the next question.
Yes. So what's the biggest challenge?
The biggest challenge was making, with Josh, making the keyword model tester that
biggest
works in the
challenge
browser.
was fixing my TypeScript, is what you mean.
Well, there's a lot of moving parts in that, and they all have to, work together and work properly for that to work. And it still only works in Blink browsers, just because the APIs aren't available in Firefox and other ones. But a lot of browsers are Blink browsers now, so it's not terrible. And Firefox should, add it, but we don't know when. But still, it's a pretty cool thing to get working. It just it is challenging.
Yeah, super neat, super unique, and I think it really pushes like the state of the art of browser support for voice interfaces. We're on the edge as these things go. Unfortunately, I mentioned Firefox earlier. Like it's a bummer that that they're behind the browser. That they're behind the Blink browsers in this regard, because they were in a lot of ways leading, putting voice interfaces in to the browser initially. So
Safari
Firefox
as well, but they're a little more secretive about what they're going to do.
Right.
Yeah.
Yes. Yeah.
That's true. I totally should have said that. That was definitely the biggest challenge, because I wrote the first draft of the browser thing, and there were a couple of dark days in the middle there. Is this even going to work? It works.
That's awesome, and you'll get to see that again. Like, so we use everything that we create for Spokestack. We're using internally, so you'll get to see the how the browser, how the node support works in the browser when Josh gives you the walkthrough of Spokestack Maker web interface, because when he tests things out, or when he shows things running, like that's actually what we're using is Spokestack node running inside of the Spokestack website. So that kind of dog fooding is a really good signal to me that these things are actually useful and valuable. So that's the team. Thank you all for showing up. I really appreciate it. Josh, you have a walkthrough of Spokestack Maker to show everybody. So take it away.
Do I? Yeah, sure. Let's do that. So what I'm going to do here is I'm going to share a browser window, and you're going to tell me in the chat if can't see anything. And if not, I'll just assume everything is good. And okay, there we go. Get over to the window myself here. All right, so we're going to go through every main feature in Spokestack Maker. And for each one, I'll stop a bit and say what the feature is, what you generally use it for. We'll walk through the UI a little bit on the site, and then I'll just talk really briefly about how to use it in an app. As you can see over there on the left side, there are four main services, four main features that we'll be talking about. But luckily, the UI is pretty straightforward. We're a little biased to say that maybe, but the UI walkthrough shouldn't be too overwhelming. We're not going to be showing a lot of flowcharts or a lot of complicated things. All the complication is in the back end. You don't have to worry about it. So we'll start at text-to-speech, apparently the unanimous favorite feature that we have. And the text-to-speech interface is right here. It lets you sample from our existing voices. Spokestack Free up here at the top is the default one, and that's the one we mentioned as having been recorded in a Hollywood studio for many hours, and the rest of them have varying degrees of data associated with them. For each model, you can see the source data that was involved in it. But what we're interested in for the Maker walkthrough is the custom models you can make. So you go up here to the top, create a model, and you can go ahead and give it a name. I'll name it Livestream, because why not? And once you've named your model, you go straight into adding utterances to it, adding recording samples. And to do this, this is your AI voice clone. And since deepfakes are a thing and deepfakes are a bad thing, we will choose the scripts that you record. We have a bunch of scripts on the back end that you will record using your computer microphone. USB microphone is great, gives a little better quality. And that serves as a form of consent. You can't just upload audio of a celebrity, of a relative or whatever without their consent to create a voice clone of them. You have to do it using our interface, and that's sort of how we get that layer of safety in there. So I'll show you how the recording actually works. You click record. This modal dialog will pop up, and we've got some instructions down here. I'll just summarize them for you. Use the button up here to start recording. And once I do that, a progress bar will start counting down. You have 10 seconds to finish the scripts. All of these that we show you should fit within that 10 seconds pretty easily. And as I'm recording, you'll notice the words will light up blue. That's speech recognition on the back end going along and verifying the words that it's hearing. The ASR it's meant as a guide, not a judge. So if it doesn't catch all the words, but you said the phrase that's on the screen, go ahead and click upload here over on the right. It's not going to penalize you or anything like that. It's there to kind of backstop things and say if there was a real error with your microphone or whatever, you can click preview over here to double check that and see if you want to go ahead and upload the sample. So I'll just do this first one here. Well, here's a story for you. And if it detects all the phrase completely, it's going to stop the progress bar early, and the whole thing will light up blue, and you're good to go. If it doesn't, if not all the words are blue, the progress bar will continue to count down, and you can go ahead and click this button again to stop recording and upload your sample or preview it if you want to. I'll just leave this alone for now. So one of the great things about our TTS voice clone is that no other service that I know of matches the quality that you get from the resulting voice, the time investment that you as a user put in. We require about, roughly speaking, 5 minutes of audio. So you see down here at the bottom, we require a minimum of 75 samples. So that works out to about 4 or 5 minutes when you average out the script times. And so no one can match our quality at the time investment at our price point. Maker's very reasonably priced. I would actually go so far to say is that I don't think any other service that I've seen can match 2 of those things. You see services that will offer to give you a true Hollywood TTS voice, and that's going to cost you multiple thousands of dollars. You see other services that will let you do it self-service that require more audio, but I don't think anyone matches us on all those criteria, or even 2 of them. So I said I was going to talk about what you use each feature for, and clearly a custom TTS voice is a replacement for the voices provided by the big platforms. So you can even go so far as to use your Spokestack TTS voice in an Alexa skill instead of the default Alexa voice. You can generate all your responses dynamically, run it through our TTS. It runs faster than real time, so you're not going to have any have any latency issues where Alexa kicks it back to you and says we couldn't get the response in the amount of time we needed, we have a tutorial up on how to do that actually for Alexa specifically. You can use it in a home automation setting. This is great for doing notifications via Home Assistant. You know, like you're not home in the afternoon, you send a message to your Home Assistant system and it announces in your voice, hey, it's time to do your homework. So, and then of course there's the whole prank scenario where you can make Alexa sound like you, and I'm not gonna guess what you want it to say, but whatever. So how you would use this in an actual app is through our libraries that Noel mentioned earlier. You put in your Spokestack credentials, and that will give you access to any of the voices that you have trained on your account. And so you have a name right here for the voice, and you just pass that name in with your TTS call, and the audio will come back in that model, in that voice. So moving along, because that took me a while to do. Let's go on to wake word. So wake word is, we're pretty familiar with this by now. It's the thing that responds when you say Alexa or okay or hey Google. And my phone probably just triggered for saying that. So it's what's used to activate speech recognition on the back end. So before the wake word happens, the app is not actively listening, not processing audio. After the wake word happens, it starts processing what you say until you stop talking, and then that's treated as the command to the app. So one important thing to note about our wake words in Spokestack is just because it says wake word singular in the model, you can have multiple actual wake words or wake phrases. So if you want to use your app name and then also support hey in front of your app name or okay in front of your app name, like Google, you can do that. And so let's, before I go into the creating your own model though, I will note, since Noel just mentioned this, that we have a test tool right in the page here, and this runs Node Spokestack. There might be a little bit of microphone interference with my headphones and a little bit of lag because of the live streaming, but let's see how well this works for the stream scenario. Spokestack. There we go. So it did work without too much delay there. So you'll get when it detects it, you'll get a confidence value along with that. And I was pretty clear with my pronunciation, and there's not a lot of background noise or anything, so I was pretty confident. And then once you create your own models, they're going to show up here in the list as well. I forgot to mention that in the TTS section, your models show up at the top here when they're made. So let's go ahead and make a new wake word model. Call this one live stream as well. And like I said, you can have multiple wake phrases or wake words that wake up your app. So that's what an utterance is. It's a single instance. It's Spokestack is one utterance. Hey, Spokestack would be a second utterance. And so what you do is you don't want to make these too long, but 1, 2, maybe even 3 short words should be fine. And once you enter your name here, the record button is going to pop up something very similar to the TTS thing, except instead of our scripts, it's going to be your utterance. So I'm actually going to go ahead and go all the way to training one of these so I can show you the next step. Live stream. Live stream. Live stream. Live stream. Okay, so we require 3 samples per utterance to train a model. And the rule for this is the same as the rule for TTS. The more samples, the better. But no matter how many samples you give a personal model like this that we're offering on the Maker tier, we wouldn't recommend deploying it in a production mobile app that's going to go around the world or even around the country, because these models, especially wake word and keyword models, are small. They're small so that they can run on a mobile device in near real time, as close to 50 times a second as possible. And so they're highly optimized. And the voices you train them on are going to be the voices they're most accurate with. That's not a guarantee it won't work with other voices, but as soon as you start throwing in different accents, different styles of speech, and everything like that, your accuracy level is going to go down. So in order to train a full production universal wake word model, you need data from a lot of people with different voice characteristics. So you obviously don't have that when you're recording yourself. So if you want that, we can also do that. So get in touch. But I'm going to go ahead and click train here since I have the minimum number of samples. And you'll see the box grays out. We got a little blue progress bar down here at the bottom. Usually command models, wake word and keyword models take just a few minutes to train, but they can take longer depending on volume of requests and things like that. So you'll also get an email when it's done training, and the page will refresh and it'll show up here in your tester. But we're not going to wait for that whole thing here. We're going to move on to keyword. And the thing that wake word and keyword models are very similar, but for one key difference, two, depending on how you split them up. A keyword model is actually a form of limited ASR. So a keyword model will actually give you back the transcript of what the user said. A wake word is just going to send you an event. It's going to say, I heard the wake word, ASR should start now. A keyword model is going to say, I heard Spokestack, or I heard another keyword that you put in there. And so a keyword model is useful for lots of limited resource environments. Like this works entirely offline, just like the keyword model. And it can work for a number of different commands. So say you're making an app that is meant to play music while someone is running off in the woods and they don't have internet connectivity. You make a keyword model with things like volume up, volume down, pause, skip, next, back, things like that. And you can control your app without running a full ASR model or doing any cloud requests or anything like that. So the UI is very simple. Sorry, I meant to say very similar to the wake word model, except for the fact that instead of utterances down here, you have keywords. And I will tell you what that means as soon as I fill this out. Each keyword can have multiple utterances. And this is, I'm going to change the text here, this one, to really show you what I mean. Let's say that my keyword model is going to be for a camera. So I'm going to make a keyword that says photo, as opposed to video, because smartphone cameras do photos and videos. So my utterances are going to be take picture. I'm going to add another one that just matches the name I have up there, photo. And so what this means is, go back here, I have one keyword, which is photo, and two utterances under that. So whenever a user says take picture or photo, my app is going to get the transcript of photo, of the keyword name. And that's to make it easier on you, to help you multiplex different commands into a single canonical word or phrase. So make your keywords whatever are most useful for your app, and then put whatever different forms of that utterance, that keyword you want as utterances. And you have to record, again, 3 samples for each utterance. So it's not 3 samples per keyword. You want 3 samples of take picture and 3 samples of photo, and then the train button will light up. And I haven't talked yet about how to use either wake word or keyword in an app. And that is dependent on the profiles that you set up using our mobile and embedded libraries. So in the Spokestack libraries, you will get an opportunity to use a wake word plus a native platform ASR like Android or Apple. You can use a wake word model plus a keyword model as your ASR. And that's all That's all covered in our documentation. So the last thing is very straightforward, and it's something that's been a part of Spokestack from the beginning. It's the NLU import. And this is something that a lot of us who have made voice skills or voice-enabled apps are already familiar with. This is what takes from a full-fledged ASR, not the keyword we just talked about, but if you're accepting commands as full natural language sentences, this is what takes them and translates them into commands that your app can use. And so you provide us with training data for your app that says, take a picture, snap a photo, I'll go to an intent named take photo or whatever you want to name it. And this will inform our NLU module. We'll train a TensorFlow model for it, and it also works on device. So as soon as ASR is done with its transcript, the transcript goes through NLU and a command comes back out of the NLU to your app. So when you go to make an NLU model, we support a number of different platforms. You can export an existing NLU model if you've used Rasa, if you've used Alexa, if you've used Dialogflow. We can convert those. We do recommend that you use our training data format if you're starting from scratch, or if you have the time to rewrite it, because we support a few different things that those other formats don't. You can read more about that in the documentation. But all this is a simple file upload, and you give us a zip file of your Dialogflow agent or your Spokestack training data or a JSON file from Alexa, etc. And we will convert it. We'll send you an email when it's done, and you will be able to download a TensorFlow model. These are shared models, like it says right here, available to all accounts that you can download to try out. These come from different sample Alexa skills that Amazon has published, and we've just replicated that functionality here so you can try it out for yourself on a mobile library. And I think, let's see if the wake word is done training. The wake word is done training, and you can see how it pops up here. And since it's done training, let's go ahead and try it with my 3 utterances that I gave it. Live stream. Hey, what do you know? I honestly was not actually planning to demo that, but there we go, done. And I think that about covers it. If I left anything out, do let me know in the chat, let me know in the Q&A. But I have talked quite enough at this point, I think. So I will give the mic back to someone else.
Thanks, Josh. It's always great when you're running a demo and it actually works the first time without there's always that little bit of
Yeah, I don't think that's ever happened.
Yeah, they're gremlins. They're usually gremlins. And I think one of those utterances might have even got crosstalked through my headphones. So I'm not even sure I had 3 full utterances there. Nice.
That's awesome. Yeah, it similarly worked in another demo that I did a couple weeks ago, and I was always pleasantly surprised. So that was a great overview of the features of Spokestack Maker, kind of walking through how to create these custom machine learning models for voice using Spokestack Maker. Just to tease, we are going to be making some more videos specific to the platforms that you as developers are interested in. So we're going to cover Python and iOS and Android and Node, and walk through with you how to use Spokestack Maker to both create these custom models and then run them on these different platforms in your favorite language. So keep an eye out for that. We did say that this was a Q&A. We have a few questions that came in offline that I can highlight for you guys. So format will just be I'll throw out a question, and whoever feels the most capable of answering can pipe up. First question is who should use Spokestack Maker? I can take that one actually. We created Spokestack Maker for developers, specifically for independent developers, for startups, for people who are prototyping new applications, for students. So we've actually had like a good amount of uptake in students using Spokestack as part of their class projects. And so for all these people, what's important is like, I want components of a voice interface, and obviously I want it to be a custom voice interface. I don't want to break the bank in making this. So, you know, Josh hinted at the previous cost of creating these custom models and running them. And then they also want, you know, a full platform support in their favorite programming language. So if you're identifying with, you know, any set of those, then we made Spokestack Maker for you. We don't want this to be a corporate tool. This isn't an enterprise tool. This is something that we made for the creators and the makers and the prototypers and the startups out there, the independent developers. So we want to put it out there for you to use and see what you're going to make. And that's really motivating for us to give this tool out there. And we're excited about what people are already using it for and what see it grow. Next question. What platforms can I run the models I create in Maker? I'll throw it to the panel.
Well, iOS, Android, React Native, Node, /browser, and am I forgetting one?
Python.
Python. Yep, that one's good.
Nice. Yes. Great. Thank you, Timmy. What languages do you support?
Well, it depends sort of, because a lot of these platforms use multiple languages. Like you can write an Android app in Java or Kotlin. You can write a iOS app, I think, still in Objective-C if you really want to. So we support all the languages that those platforms support. For Android and iOS, the libraries are written themselves in Java and Swift / Objective-C where absolutely necessary, respectively. The React Native library is a mix of native Kotlin and Swift and JavaScript, correct, Timmy?
Yep.
And there's TypeScript for the Node library.
And then if you mean non-English, we're looking at multilingual support soon.
Yeah, mostly still experimental at this point, but working towards it.
Well, importantly, wake word and keyword are multilingual off the bat. So you already got that going on for wake word and keyword, which, you know, brings you a good bit of the way into having multilingual voice interfaces. So you can activate your software with in any language, really with any sounds, and then you can issue commands to your software, voice commands in any language using our keyword models that you train in Maker. So
that's true. And sorry, I didn't mean to interrupt. If you use the platform provided on device ASR, usually that will support whatever language your device is set to.
Right. And I know, Josh and Will, that you guys have been working with some customers who have been asking for multilingual NLU, and you've had some good results from that, particularly around Romance languages. Is that correct?
So far, well, we've had, let's see, some of those would have been Romance. One would be Slavic Germanic. No CJK yet. I know the libraries will be a little behind on that. We'll have to update the libraries for true CJK support. But yeah, European languages are so far so good.
Yeah. So I mean, the answer is a little bit complicated. Yes, there is multilingual support. It it does depend on the component, but multilingual is something that we are working on actively. And the same for supporting other programming languages and platforms. We've gotten a few requests for Flutter, and that's an intriguing platform to examine doing support on. So yeah, thanks for those answers. I think this is probably a good question for Will. What embedded devices do you support?
So right now we work on the Raspberry Pi 4, any of the larger ones. It works pretty well on the Zero, but then you go smarter than that, like the Pico or some of the other devices. I just blanked, sorry. That run MicroPython. We actually don't run in MicroPython right now, but that's something we're looking at. Or maybe just spinning off a embedded library that's separate, strictly for the smallest embedded devices.
Cool. A question. This is actually a question we get a good bit. How is Spokestack Maker different from what Jovo and Rasa are doing? I can answer that one. So Jovo and Rasa are conversation and NLU designers. So they specialize in connecting the products of the ASR, the transcripts, and then giving your software the ability to respond to what's being said using NLU, and then telling your software what to say back in response. That's dialogue management. So they specialize in the dialogue management and NLU components. We actually interop with both of Jovo and Rasa, so you can design your conversation in them. You can actually export into Spokestack and run your NLU inside of Spokestack and run your dialogue management through Jovo or Rasa to get back your responses, and then use Spokestack TTS to actually speak your responses. So Maker is different from Jovo and Rasa in that it supports wake word, keyword, ASR, NLU, TTS. Jovo and Rasa are much more focused on just the NLU and dialogue management pieces. Anybody want to add anything to that? Cool. Okay, another question. How is Maker different from Siri and Google Assistant? Siri and Google Assistant, those are kind of those are general purpose, platform specific, like virtual assistants, and so it's kind of what Spokestack is doing is not intended as general purpose. It's intended to be limited to your software. So putting a voice interface for your software, not answering any question possible, like my kids do with Alexa. So basically, you can think of them as like general purpose virtual assistants. You can think of Spokestack and what you can make with Spokestack Maker as putting voice interfaces into your software, which, if you've ever tried it before, is impossible using Siri and Google Assistant. You can actually open your app, for example, using Siri. And same with Google Assistant. You can open it with them, but the conversation actually stops once you open your app. So they don't actually provide any more voice interactivity once your app is open. With Siri, you can like donate intents and whatnot back into Siri from your app, and you can. Then your user is just toggling back and forth between Siri, interacting with Siri and interacting with your app. It's a confusing experience, which is why you don't see a lot of people supporting it or even using it. So what Spokestack does is different. Spokestack gives you a voice interface so that your user can interact via voice directly with your app. There's no third party that they have to. If you're having a one-on-one conversation, like a third person butting in and telling you what you actually meant with each other, that's not great in a party, and it's also not great, for your software.
And it's worth saying that there's a useful symbiosis between Spokestack and the platform assistants, because opening your app, or even doing what they're trying to do now, which is deep link shortcuts into specific app features, is great. So you can start the experience with your voice on your phone, and then your app can take over once Siri or Google Assistant's part is done. And that's what we're trying to emphasize here, that once the user is in your app, it should be an experience that's mediated by you, not by the platform. And the platforms don't even appear interested in helping you do that via voice currently anyways. So they all have interfaces that you can use. You can use their ASR and their TTS piecemeal if you want, but it's not that pleasant. And that's why we have a library to wrap those things for you.
Yeah, that's exactly right. Thanks, Josh. Okay, another question coming in. For an advertising agency, what's the use case for Spokestack Maker for that sort of potential customer?
I'm happy to take that one, but I don't want to take it away from anyone else if anyone else wants to. No?
Go for it.
No? Okay. I actually think the Maker tier is a great introduction for an agency. It's a great use case, because what an agency does, what a contracting firm does, is make apps on behalf of clients. And so you want to be able to show your clients the app's full feature set. But in advertising that you make voice interfaces, you obviously have to show the whole experience, including ASR, NLU, and the voice thing. With Maker, you can advertise as an agency that you can provide a custom branded voice for your app, a custom branded wake word for your app, or even limited keyword ASR like we talked about earlier. And you can demo all of those things in your demo using a subscription to Maker, which is currently $10 a month or $100 a year. You can demo those very advanced features without a huge investment up front. And then if the client wants to go whole hog on it and get a Hollywood actor in a studio to record a custom branded voice that's a higher quality, or that they have a specific actor that they use, they can go ahead and do that. And you could still use that voice via Spokestack. But it's the demo opportunity that I think is huge for agencies.
Great, that's a great answer. Yeah, totally agree. Okay, this one's a fun one. We're coming to the end. What's the weirdest thing you think Maker could be used for? I am interested in this question as well.
I was going to say, you wrote that one for yourself, didn't you? I happen to know. Will's got a good one or two, I think, too.
Yeah.
Yeah, I'll take that. So one of the things I thought about is doing a wake meow. It's like, basically I have cats, and so you record your cats for the wake word, and then you can, well, actually you could use keyword model if you have multiple cats, so then you can classify which cat is meowing at that time.
That's great. Wake meow. Anybody else have a weird have a weird thing that they've thought of?
I mean, you could in theory use it to tune an instrument.
Mm-hmm.
That's something we've talked about.
Yep. Yeah, you totally could. Again, these tools, especially keyword and wake word, are really sound recognition and classification tools. And so, if you think more generally, a sound is an instrument notes or chord, and so you can classify that and tell whether you're sharp or flat or on tune. Cool. I think that's it for the questions. Thank you all for participating. This has been fun. I'd like to tease one other upcoming feature that we have. So we hinted kind of we talked about the idea that Spokestack Maker is for creating personal models for prototyping and experimenting and using in your own house and that sort of thing. That begs the obvious question: what do I do when I have a successful prototype and I want to take it to production? I no longer want a personal model. I want a universal model. And so the next feature that is on our roadmap that we will be launching is Spokestack Pro, where you can take the models that you define in Spokestack Maker. And again, with just a couple of clicks, no code, you can train them using thousands and thousands of pieces of audio data. Again, custom audio data that you don't have to do anything to create. That we will handle for you. And your model then will no longer be just a personal model. It'll be a universal model. It will be able to be recognized. It will recognize speakers, not just you, but it'll recognize everybody who says the keywords or the wake words. And so that would be that's the next step in scaling your prototype up to a full featured and distributable, releasable application. So that's the tease for what's coming next out of Spokestack. Again, the maker features are great and they're out now, and you can totally build stuff with them and you can play around with them. And when you're ready to go to production, we will have you covered with Spokestack Pro. So that's a little tease for what's coming next. Thank you everybody for your time. Thanks everybody who's listening. Have a good afternoon. Keep listening.